Hello guys, welcome to third section of Android application tutorials, reactive design. In this section, we are going to learn the basic concepts of the reactive programming, and in next section, we will implement reactive design in our sample project. So, let's start with our first topic of this section, which is inflows, outflows, and marbles. In this video, we will start learn what reactive programming is, its basic concepts, and marble diagram. So, what is reactive programming? Reactive programming is a programming paradigm oriented around data flows and the propagation of change. This means that it should be possible to express static or dynamic data flows with ease in the language used, and that the underlying execution model will automatically propagate changes through the data flow. So, why should you care? As you see in the given example, we take the first name and last name from two input fields, generating the full name with greeting, which is then append before the full name. We are also updating the UI greeting label as the user type his/her name, all this in just 3 lines of code. Without Rx, if we were to implement the above example without Rx, we would register two global variables, first name and last name, register callbacks for changes in those two text fields. During each change in either text field, call a function that verifies if both first name and last name exist. Finally, in the form of valid, create greeting text and update greeting label. Thanks to RxJava, we don't need to do all these steps. We can do this task in 3 lines as shown above. So now, the 4 principles of reactive programming is responsive, resilient, message-driven, elastic. Responsive. Responsive basically means that the system should be fast and provide useful feedback for user interaction and error conditions. Resiliency. Resiliency is immunity to failure. A resilient system fails rarely and stays responsive even after failure. Elastic. Elastic means the ability to handle varying amount of work. Reactive system scales well under heavy load conditions. Message-driven. In reactive systems, the data is a stream of events. These events is passed between components notifying them about new data, error conditions, and completion of data. Technically, Rx is a mixture of different patterns like iterator pattern plus observable pattern plus scheduler. Iterator pattern is a design pattern that provides a way to access a collection of elements sequentially. Collection provides an iterate method that returns an iterator which is used to access each element of the collection. Iterator pattern is a pull-based mechanism, meaning the consumer is responsible for calling the iterate method to get data from the collection, or producer you can call it. Observable pattern, on the other hand, is a design pattern where a subject maintains a list of dependent. Here I refer subject as a producer and dependent as a subscriber, and it notifies them of any state changes by calling one or more of their methods. It is a push-based mechanism, meaning the producer is responsible for notifying the consumer about the data changes. Scheduler by default, observable sequence will observe event and react to them in the same thread. Scheduler are thread abstraction for performing concurrent and asynchronous work. They help distribute work amongst multiple threads. They are specifically useful in mobile programming, where a dedicated thread called main UI thread is used for handling any UI changes. Now discuss main component of our reactive programming. There are three main components: observable, observer, and subscriber. Observable. Observable data is data source that is create events. It provides data to observer using onNext function, notify that an error has occurred using error function, notify completion of stream using onComplete function. This is the sample example of observable. Observable tree, subscription, subscribe, final, observer tree, and observer. Now second type is observable, which we are subscribing in observable. So observer. Observer subscribe to an observable, get notified to next, error, and completion event. Primary reason why threads are not blocked in reactive programming. On next. On observable calls this method whenever observable emits an item. This method takes as a parameter of the item emitted by the observable. On error, an observable calls this method to indicate that it has failed to generate the expected data or has encountered some other error. It will not make further call on next or on completed. The on error method takes as a parameter as indicated on what caused the error. On completed, an observable call this method after it has called on next for the final time if it has not encountered any response. Subscriber. A subscriber is an observer that can also unsubscribe from that data source through the subscription interface. We will study observer, observable, and subscriber in more detail in our next tutorials as well. So now, marble diagram. RX uses marble diagram to explain how any operator works. Marble diagrams are very convenient and easy to understand. So this is the example of marble diagram. This first line above the box indicates the raw data. This data need to be emitted by the observable. Different types of objects are displayed with different shapes. Box in the middle indicate operator. There are many other operators available that basically control when and how the observable should emit the data. We are going to look into those operators and further. The line below the box indicates the data that is emitted by the observable. Observer in RX receive this emitted data. Let's discuss in more detail. As you know, observable is nothing but a function that emits the data stream. Below is the observable that emit 1 to 5, one after another. Here is called as an operator. It emits the value provided in arguments. Third example, sometimes we want to refine specific event only to be emitted by observable. Let's say in our above example, we only want to emit only odd numbers out of these observable. We can achieve this using another operator called filter. As the name suggests, filter operators filter items emitted by an observable. So that's all with the marble diagram. So our next topic is going to be a different types of observable: single, maybe, completable, and observable.